Good morning. Welcome to NGSS Physics. This is Ms. Cook. Today we're going to be using algebra to solve for variables and equations. It's going to be very important to us in physics because there are quite a few formulas that we're going to be using, and those formulas are jam-packed full of variables, and the formulas themselves can't be changed. So we have to, if we're interested in one variable, we need to be able to manipulate the formula to get to that variable, because the formula is basically a mathematical model of known relationships in the universe. So we need to be very careful about how we do that. First off, what is a variable? Well, in an equation, a variable is something that we are interested in, and it's a quantity that can change based on the other variables because there's a relationship involved. And just to give you an example, I'm going to show you the physics reference sheet here in a minute. The physics reference sheet you're going to be able to find in Google Classroom. It's attached to your syllabus. So look in the stream section for the little booklet on NGSS Physics. And I recommend printing out the reference sheet if you can. Here is physics reference sheet. This one has a front and a back to it, but you'll see quite a few pages. You can see jam-packed full of formulas. This is what I mean, mathematical representation. And we've got some letters representing. Here's one that's probably familiar to you. Speed is equal to distance over time. And to show that in a mathematical formula, we use some variables like s, d, and t, and those variables all mean something: speed, distance, or time. And you can probably guess that. S stands for speed, d stands for distance, t stands for time. Well, yes, variables in physics, although we can use any sort of letter in a mathematical formula like A, B, C, X, Y, and Z, in physics, we use very specific letters for specific values. And on that formula sheet, you'll see those listed. Getting familiar with those will benefit you. For instance, if I go back to the formula sheet here in a second, we're going to see that, the letters have specific meanings. Let's go back there for a second. You'll see down here, I've got little g. Little g represents gravity, and gravity on Earth has a distinct value, negative 9.8 meters per second squared. Of course, gravity on the moon or on a different celestial object, will have a different value. But for Earth, we can guarantee it's negative 9.8 meters per second. Now, big G does not represent gravity. Big G is a gravitational constant. You can see that little g right above it. That's the acceleration due to gravity. And on Earth, it's negative 9.8 meters per second squared. So physicists really use distinctive letters to represent different variables. And getting familiar with those will benefit you. Okay, so manipulating those variables when we have an equation, what is that all about? Well, going back to some of those things that you learned in math class long, long ago, you probably learned what an equal sign is. If you take a look at my arrow here, I'm going to move it down right there. It means that whatever is on one side of the equation is exactly equal in value to what's on the other side of the equation. It's kind of like having a balance. What I do to one side of the balance, if I do the same thing to the other side of the balance, it stays equal. And that's the relationship between those variables. And that relationship, again, is a model, modeling some kind of a physical quantities and physical theory that we have looked at in the universe. And so by maintaining that equals, we can keep that relationship in the formula, even if we're moving the variables around. Okay, so how do we do that? Here's an example of a very simple equation. X plus 5 is equal to 7, and we're interested in the variable x. What is the value of x? Well, you probably know that, all I need to do is get rid of the 5, What I do to one side of the equation, if I get rid of the 5 here, I have to do the other side of the equation. How do I get rid of the 5? Well, if I'm adding 5, I could subtract 5, but I have to do it to both sides of the equation. And what ends up happening is 5 minus 5 is 0. I get x by itself. 7 minus 5 is 2. I get a value of 2. Sometimes you might like to think of it as moving this to the other side, especially in a very easy equation like this, where there's only one variable. Okay, so here's that equation again. You could think of it as, oh, I'm just going to move the 5 to this side because we're moving it across the equal sign. Whatever symbol that we have on this side, we want to do the opposite because we're moving it to the opposite side. So instead of a plus 5, when it moves to this side, it becomes a minus 5. The answer that you get is still going to be the same. X is equal to 2. So a good rule of thumb to keep in mind for addition or subtraction, when you change sides, change the sign. Or you can think of, oh, what I do to one side, I do to the other. Sometimes it's not going to be in addition and subtraction. A lot of times in physics, we have multiplication and division. We have fractions in our formulas, like the speed equation has a fraction, d divided by t. So how do we manipulate variables that are in fractional form? Well, you can use the numerator-denominator rule. Again, if you move something to the opposite side of an equal sign, you want to do the opposite of what is happening to it. For instance, distance divided by time. Instead of dividing by time, if you move it to the other side, then you multiply by time. Or you can think of it as, what I do to one side, I do to the other. So let's take a look at an example of that. Here it is, multiplication and division. We have a very simple equation. 5x is equal to 7. What does the x equal? So it's being multiplied by 5. So if we do the same thing to both sides, how can we get rid of that 5? Well, 5 divided by 5 is 1, and we can get rid of it that way. But we'd also have to do it to the other side, just like that. So 5 divided by 5 is 1. It leaves the x by itself, and you got 7 over 5. Plug that into a calculator, you can resolve it to 1.4. Of course, you could just say, oh, I need to move the 5 to the other side. Moving the 5 to the other side is simple. You got it multiplied by 5 here. So if you move to this side, things have to be divided by 5. And you get something that looks like that. So for multiplication and division, when you're changing sides, change the position. If it's on the top, put it to the bottom. If it's on the bottom, put it to the top. Now, when you see a number all by itself like this, that means it's on the top, just like this number over here. Okay, we usually don't put the 1 that's on the bottom. Anything divided by 1 basically is itself. It's like a puzzle. That's what we're doing here when we take equations and we're solving for variables. Okay, and when we solve a puzzle, there are some things we can do and some things we can't do. Pieces don't just fit together any old way. They got to fit together a certain way. So keep these rules in mind. If you are one of those people who just think, I don't like math, it's so hard, write down these rules, and these are going to help you. And then join me a little bit later in the class period, and I will go through some of the examples at the end of this lesson for you, or join me in the hub. Add or subtract the same value from both sides. Okay, so for adding and subtracting. To clear out fractions, you can multiply by what's on the bottom. And if there's another type of function, like a square, like something is squared, you can apply the square root, and that eliminates the square. Okay, so whatever function is being happened that you want to move to the other side, just do the opposite of that function, and you should be good. One thing we can't do is we can't make up our own equations. Let's go back to that equation sheet for a second. So in other words, let's say we were using the speed equation right here, and we wanted d, the distance. We were given the speed, we were given the time. We can't just make up a formula and say that distance is equal to speed divided by time or whatever we dream up. We have to keep this relationship intact. And so we have to use those rules that we learned in math to do that. And that is what manipulating formulas is all about. Okay, here's a third example, more complicated. Let's say you have an equation like this. Now we got a lot of variables in there. Sometimes when there's lots of variables, people get excited. I don't like it, okay? We don't necessarily have to have a single numerical answer for this one. We might have a formula that develops. What would the formula be if we wanted to solve for A? So let's take a look. Here's A up here, okay? We would just want A. What is A equal to? Well, we need to get rid of some stuff. We need to get rid of the 7, and we need to get rid of the B. So move the B to the other side. Since it's divided by B, I'm going to be moving that B to the top over here. Or multiplying by B on each side cancels it out, and it puts the B on the top. Okay? Just like that. Once we get the B on the top, now we've got 7A. What that's equal to? Well, we need to get rid of the 7. And since it's being multiplied, we could divide it. Or we can move it to the bottom. Okay? So we're going to move the 7 to the other side, which is to the opposite of what's being done to it. And here we go. Here's our formula. A is equal to x, y, b, x times y times b, divided by 5 times 7. Now, we can resolve the 5 times 7 if we wanted to, okay, in a calculator. But unless we have numbers for the other variables, that's as far as we can go. Okay? So resolving the parts that you can resolve, and if there's other variables you can't resolve it. Usually in an experiment, you'll probably be measuring something for every single one of those variables and be able to resolve it. Okay, so let's take a look at another example. Okay, this time we'll use that same equation, but instead of isolating A, let's try isolating B. B is on the bottom. You see that? And if we move these two down here, we wouldn't get B, we'd get 1 over B. So, when you have a variable that's on the bottom of the equation, first thing you need to do is get the B to the top, because you don't want 1 over B, you want B. So move B to the other side. It's got to be on the top. So to do that, instead of dividing by B on each side, we're going to multiply by B on each side, move it up there, and we get this. And it looks like we got more complicated than less complicated, but at least it puts the B where we want to go. So now we just need to manipulate the rest of those. You can see that X and Y needs to be moved to the bottom, and the 5 needs to be moved to the top. So we'll move everything else in the right directions. 5 up there, X and Y down there, and we get something that looks like this. Now you can see I have 35 because I resolved the 5 times 7 part of the equation. Anytime that you can resolve a part of the equation, go ahead and do it. So B is equal to 35A divided by XY. All right, now it's your turn to practice. I've got some equations. You can see that I've got some of these equations. This equation for circumference you might recognize. Here's the equation for force. Go ahead and practice those. There's going to be a spot in your notes to put the answers. I would use a separate sheet of paper to work these out. If you are having problems, you can ask me. Okay, when we get back to the Zoom meeting, I am going to be taking questions and solving these problems one by one if you need them. And then if you can solve these, if you're fairly happy about it, there are a couple of challenge problems that you can try as well. Can you solve for R? Now we've got the square function. Okay, remember the opposite of a square function is a square root. Okay, and we've got multiplication and adding and subtracting mixed together. Okay, so remember the rules that you use for math. What comes first? Multiplication and division. What comes second? The adding and subtracting. Okay, well, thank you for listening. If you need to go back and take a look at this any further, it'll be on there, Google Classroom. Go ahead and look at it. Make sure that you fill out your Google form and turn it in. And signing off.